Okay, so you might like that there's no graphs on this piece of paper. Yay! We are solving for x. Now they will come back tomorrow. They on a number line is the graph we're gonna do today is a number line. Tomorrow the graphs will come back. It's gonna be more like analyzing them though, and just taking it up a level and it's just absolute value graphs that we're gonna look at tomorrow. So today and tomorrow is all about absolute values. And then Friday, we are going to look at piecewise functions, which I told you is your first like honors section. Your other friends that are in general won't do piecewise functions. And those are related to absolute values as well. Would you agree that an absolute value is two pieces of lines connected out of our text? So that's like the most basic piecewise function. So we'll build on that. But today we get to solve for x. Yay! We all love it. So with absolute value, though, before we get into inequalities of them, let's remember how to solve just an equation of it. So if I have m minus 4, the absolute value of m minus 4 equals 6. Do we agree that inside that absolute value could be 6 or negative 6? So technically there's two things I could plug in, right? Because if I have the absolute value, try this again. If I have the absolute value of 6, that's going to be 6. Or if I have the absolute value of negative 6, which would also result in a positive 6, right? So what's in my parentheses, this m minus 4 is allowed to equal 6. It's also allowed to equal negative 6. Both of these cases, you should add 4 over. Over here, 6 plus 4 is 10. Over here, negative 6 plus 4 gives you negative 2. So absolute values will have two solutions, which again, doing some throwback connection here, solving for variables like this, you're solving where your graph crosses the x-axis. So would it make sense that your v crosses the x-axis at two spots? Yeah, that would make sense. Okay. So we're saying that this is like little bonus content for you. This is crossing the x-axis at negative 2 and 10. That's what that's essentially showing, which we'll need to know tomorrow. Okay, so when we're solving here, we're solving for two different values, two different x-intercepts. So part B, when we have x plus 2, the absolute value of that can equal to 3. To set it up, I'm going to say that x plus 2 can equal 3, but x plus 2 could also equal negative 3. Sorry. There we go. Does that make sense about why we're doing two equations? Are we good? It may lost. Okay. Because what's inside your bars, right? Whether it's 3 or whether it's negative 3, those are both going to end up a positive 3. Absolute value is always the positive because we're showing a distance from 0. So x plus 2 is in the bars. So that in the bars could be 3 or that in the bars could be negative 3. Both of these we're going to subtract 2. So we're going to have an x-intercept of 1 and an x-intercept of negative 5 for this one. Okay. So when we move on to inequalities today, we're going to have that same mindset, that there's going to be we're looking for two solutions, okay? Two equations will be set up, okay? An absolute value inequality is an inequality that contains an absolute value expression. Oh, shocker. For example, yes?
Would you want both x's or just
one? Oh, always both. Yep, always both. For example, the absolute value of x is less than 2 and the absolute value of x is greater than 2 are absolute value inequalities. Okay? Remember, an absolute value of x is equal to 2 shows the distance between x and 0 is 2 units. So absolute values show distance. I think we've talked about driving cars before, possibly in this class. Yes, no, maybe? Not you guys? If you drove a car forwards or if you drive a car backwards, you're still putting miles on your wheels, right? You're still putting miles on your car. You're not going to get miles back By driving backwards. Ferris Bueller's Day Off, famous scene at the very end. If you haven't seen it, go see it. You cannot, okay? Whether you're moving your car forwards or backwards, you're still moving your car. You're still using that engine. You're still putting wear and tear on the tires, right? It doesn't matter which way you're going. That's what absolute values are showing. It's a distance. So negative just shows backwards. Positive just shows forwards, but it's still, something is still traveling. Okay? Cool. I like your hat. So let's do some inequalities. What we did up top was I made it equal to the positive and negative, right? We're going to do the same thing. For this inequality, absolute value of x plus 7 is less than or equal to 2. Okay? So I'm going to say what's inside x plus 7 can be less than or equal to 2. My second equation, we want the negative. So if I multiply that by a negative 1, what happens to your sign? It flips. So my second equation is going to be greater than or equal to negative 2. In our warm-up, we did multiply by negative 1 technically. And flipping an equal sign, it's still an equal sign, right? Here, we have less than greater than. So when we multiply by negative 1, it's going to flip that sign. You good? You with me? All right, both of these equations, we're going to subtract 7. This side we're left with x is less than or equal to negative 5. This side we're left with x is greater than or equal to negative 9. All right, it says graph each solution if possible. We're going to use number lines today for that. Okay. So here's my number line. What are the only two numbers I really care about on my number line? Negative 9 and negative 5. Okay, negative 9 is lower. It's going to go down here. Negative 5 is higher. It's going to go up here. Something else to remember about inequalities. When you graph them on number lines, you have either open dots or closed dots. Yeah? Which ones are these going to have? Closed, because we're equal to. Good. Now we're greater than negative 9 and less than negative 5. What's nice about these arrows is they point which way to go, right? So if I'm greater than negative 9, but less than negative 5, would you agree that they meet in the middle? Okay. This is an example of an and. Did you do compound inequalities by any chance in Algebra 1? Possibly? Vaguely? Okay, so compound inequalities, you typically use the word and or.
Yeah.
Okay, so because it meets in the middle, this is an and. X is less than negative 5 and greater than negative 9 because they meet in the middle. Questions? Okay. Absolute value of 8x minus 11 is less than 0. Or would be if they go opposite directions. I like the way you're thinking, but you're just not thinking of the right thing. But there is something special about this problem, though. So 0 definitely should stand out to you. And what's next to that 0? And which one? Less than. Can absolute values be less than 0? No, that can never happen because absolute values are always what? Yeah. Absolute values will always be positive results, right? So no matter what x value you plug into that, negative 1,000,000, positive 512, okay, that absolute value will still be a positive number. So it's impossible for this absolute value to be less than 0. Okay. Question, what's a little thing I could change to make this possible? Yes. If it was less than or equal to, then we could definitely do it. We could make it equal to 0. That would be okay. right? But it's not saying it can be 0. It's just saying it can be negative. So this is a never. Never. Okay? This has no solution. What do you think that means about the graph, by the way? The graph exists. There is a graph. It's just probably floating up here somewhere and just not touching the x-axis. That's what we'll see tomorrow. Okay. So it does still exist. It's just not crossing the x-axis. It's either floating above or maybe it's been reflected and it's going this way. But it's still very possible. Okay. Let's do green. All right. Absolute value of c minus 1 is greater than or equal to 5. Can we move forward? Yes, we're fine. Nothing weird with the 0 going on here. So what's the first equation we're going to set up? C minus 1 greater than or equal to 5. And what's the second equation going to look like? What's the second equation going to look like? There we go. Good. Yes. So there's my 2 equations. What's nice is they're going to have the same steps. What's the step you're going to do? Add 1. Yeah, we're going to take that minus 1 and we're going to add it over. All right. Good. So let's number line this. What are my 2 numbers that I care about labeling? Which one am I going to label first? Yep. Will they have closed or open dots? They will be closed this time. Are they going to meet in the middle or bounce away? Bounce away. Greater than 6, less than negative 4. So this is an OR problem. What conclusion could you possibly make about how to determine if it's an and or an or? How did A and C, how do they differ with their setup? Yeah, maybe less than versus greater than. Right? We have a couple below this. I wonder if the less thans will be my ands and my greater thans will be my ors. We love patterns. Right? Can you try letter A below? The 1/2 x minus 1 is less than 11. Can we try it?
My algebra 1 teacher say less than greater.
Oh, I've never heard that before. Good job, math teacher. Now I will remember it and I will use it. Less than greater thor. Greater. Interesting. Less than greater. I like it. I like it. All right, you're doing A. Okay, check with me. My pen got a little wonky. I have x is greater than negative 20 and x is less than 24. How we do? Yes, less than. Was it an and? Does my theory stay with it? Yeah, good job. How come these are open circles and not closed circles? We're not equal to. We're missing the equal to, so we're missing the fill-in. It's not there. What's up?
Open circles is always going to be and.
Nope. What does this A and the A above it have in common? Because they were both and. They're both less than. So that's what you're looking for. Riley's had a good one. She said less than. Kind of remember. Less than. And then greater should be an or. All right, lovelies. How about B? The absolute value of 10 minus m is greater than or equal to negative 2. All real numbers? How come?
Because all absolute values are greater than negative 2.
Yes. all absolute values are positive numbers. So will it always be greater than -2? Yes, there you go. Do y'all know this symbol? Have you seen it before? That double-lined R. That also means all real numbers. If you want to use that symbol, or you can definitely write it out. All real numbers. Again, you're going to learn what not real numbers are this year. So double-lined R. How would this look on a number line, by the way?
The number line.
It's just awful.
Yeah, all of them. So this is how I do it. Each teacher's kind of different. I do negative to positive infinity, and I just do a straight arrow above it. I do my graphs on top of the number line, like above it, not directly on the line itself, because if you have pencil on black ink, it's hard to see. So I always put a space so you can clearly see it. All right, beautifuls. Oh, goodness. Then there's C. What's happening here? So many things. Okay, before we make our two equations, we got to get the absolute value bars by themselves first. Okay, so I need to subtract 1 and then divide by 4 first. So if I subtract 1 over, that gives me, what, 16? And then divide by 4. And I have the absolute value of 2x minus 3 is greater than 4. So you do have to move all the extra stuff out of the way and then determine, can I actually solve it? Okay, I'm not less than 0, we're good. I'm not greater than a negative, we're good, right? So those are my special cases. We can make my two equations and continue. So I'm going to stop, you're going to keep going. Ready, set, go. All right, check your answer with mine. So we should have set it up as 2x minus 3 is greater than 4. And 2x minus 3 can be less than -4. Solve, I get x is greater than 7/2, which is also 3.5 if you have that. And then x is also less than -1/2 or -0.5.
So you're not going to require us to do the decimal form of it?
It depends on what the directions say. If it says put it in decimal form, then do what it says. If I don't specify, then it's whatever. I will say when it comes to graphing, though, I'm going to make you do decimals. So if that makes sense. So if you're already in that practice of changing it to decimal, you're in a good spot.
Changing the decimal fractions are so much easier.
I know. But when it comes to graphing, the decimals are easier. So, okay. Another throwback. Did anyone learn interval notation in Algebra 1? I think some did and some did not. So that was with like the brackets and the parentheses, equals to, not equals to. So it was a new standard that got pushed through. We're just not sure like if any of y'all fell in the gap where you might have missed it, not by the fault of your teacher. It just, you missed the year where they had to do it. So let's just refresh real quick, or maybe do it for the first time. Inequality as an interval notation. So we're going to use the lowest to the highest solution value. So it's like a minimum maximum. They look like coordinate points. They're not an x and a y value. It's the minimum and the maximum. So if I have two equals, like greater than or equals to, okay, on both sides. So if I'm closed in between two closed dots, and they meet in the middle, they're going to have two brackets. Okay, if we're not equals to a certain value, those will be parentheses. What is something that will always have a parentheses attached to it, no matter what? What number could you technically never be equal to? You can be equal to 0. I know. It's a brain teaser. You can do it. Infinity. Yes. So like in part A right here, all values that are greater than or equal to -2. Okay, well, what's the lowest value it could be? It could be -2, right? So we can be equal to -2. And what's the highest value I can be? Technically, it's infinity. So from -2 to infinity would show the interval notation, and that would get the parenthesis on the end. So -2 gets your bracket, and parenthesis gets Infinity gets the parenthesis. Okay. So if it's ever just less than or just greater than, there's going to be an infinity somewhere in there. Okay. But when you look at things like B and C, they have endpoints of where we are. My solutions are in between -7 and -4, right? So we're in between -7 as the lowest, -4 is technically the highest. Both of my signs are less than, so both of my symbols are going to be what? Parentheses, because we're not equal to those values. On the number line, they would have open circles.
So it's equal to, then it's going to go.
Yeah. So C has 2 endpoints. It goes as low as -10, but it goes as high as -1. We are not equal to -10. We are equal to -1. Like that. I wanted to throw that out there because when you do your online assignment, I believe it's going to ask for that, or some of your multiple choice is going to have interval notation, so I want to make sure you recognize what they were talking about. Okay. Ready for absolute deviation? It's going to be one of the easiest things you've ever done, I promise. I'm going to make it so complicated, and you're going to be like, why? I'm going to say because I have to. Ready? All right, on the back, real life problems. The absolute deviation of a number from a given value is the absolute value of the difference of x and the given number. Okay, very wordy. Let's look at a real life problem and see what this means. Okay, a mountain climber wants to buy a new camera drone to help map out a safe route to a mountain summit. The table shows the prices of several camera drones. The climber is willing to pay the mean price with an absolute deviation of at most $100. So let's use common sense. What do you think he's willing to pay for a camera? Willing to pay the mean price, which is the average price, right? With an absolute deviation of $100.
So like the mean plus 100.
So plus 100 or minus 100. So he can go 100 below or 100 above, right? So common sense is going to be very nice here. So that's what it's asking for, okay? It wants to know the mean price or the average price of these camera drones. So what am I going to do with these 10 values? We're going to add them up and divide by 10. There's not a mean button on the calculator.
I feel like if they come in, you can program a mean.
I mean, there might be, but we're just not going to use it right now. So 890 plus 650 plus 660 plus 450 plus 725 plus 750 plus 370 plus 670 plus 650 plus 825. Okay, 6640. Right. Okay, so you went the one step further. Okay, but when you add them up, it was 6640. Did we match that when we add them all up? Okay. And then we divided that by the 10. So we have an average price of a camera of being $664. Does that make sense what we did there? And why we did it? Because they said the mean price. That won't always happen. They just specified that for this particular problem. So now that I have the average price of these drones, okay, his absolute deviation, so the value he's willing to pay, the difference between that value and the average has to be less than or equal to his deviation of $100. That's how you would set up this inequality. Okay. Logically speaking, what's my price range?
764 to 560.
Yeah, 564 to 764, because you subtract 100, add 100, right? Logically speaking, absolutely, that's correct. Algebra 2 honors standards wants you to be able to write the equation, the absolute deviation equation. Okay, so X is the price you're willing to pay. The difference between what you're paying and the average price could not be more than $100. Okay, so to set this up, less than, I can actually set it up like this. So we can go 100 below, and we can go 100 above. So we're going to add 664 to all my sides. And there we go. So I get 564 x 764. So does my answer make sense? Yes, that's what we said. That makes sense. Cool, but that wasn't the question, was it? What was the question?
6 camera drone prices.
There you go. So 6 of them meet up with that. Does 890?
No.
Nope. Does 650?
No.
Yes. Does 660?
Yeah.
Does 450?
No.
Nope. 625? I mean 725, excuse me. Yes. 750?
Yeah.
370?
No.
670? 650? 825? No. So 6 cameras. So that went from 10 to 6. 6 cameras meet price deviation. So our climber is a negotiator. Or he just has standards. He's not willing to pay. If it's too low, it might be a crap camera, right? And if it's too high, well, he just doesn't, maybe he just can't afford it. So he knows his price range. This is what I can afford. This is what I'm going to look at. Don't even show me the other ones.
I feel like you should look at the ratings and the lower fast one before you just dismiss it.
I don't know. I'm not him. All right, we have one more. Where are you going? Are you leaving?
I was looking for tissue.
Oh, I thought you were leaving.
Why did
I have tissues. Oh, I can get you another box. I thought you were leaving me. I got sad. All right, while I get her a box of tissues, y'all try this one. You want to buy a new phone. The price you want to pay is $200 with an absolute deviation of at most $50. Write and solve an absolute value inequality to find which prices meet this condition. I understand that, but Algebra 2, you got to make sure you're using an absolute value equation. Algebra 2 honors standards need you to create the absolute value. All right, so the price you are willing to pay, that is your X, right? That's what you're willing to pay for this phone. The price you're willing to pay, the difference between that and 200 is at most $50. So less than or equal to $50. That's the absolute value equation you should set up. Okay? The difference between $200 and the price of the phone, you will not do more than $50 of a difference. Okay? So from here, you can set up your equation. So we can go down 50. Or we can go above 50. Add 200 to everything. And logically speaking, if we're going either below or above $50 from 200, we kind of knew our answer before our equation, didn't we? Yes, because it says write and solve an absolute value inequality. So this part right here, this is the Algebra 2 part of it.
So we can't solve it using the number line?
No. Nope. This is the Algebra 2 step. So we are willing to pay between $150 and $250 for a new phone. So again, reading this, you might have already figured that out. Logically speaking, the Algebra 2 side is creating that absolute value equation and showing how to solve it. All right? Good. Yeah, because we're finally solving for x. Not doing graphs. Until tomorrow. They'll come back tomorrow. They'll come back tomorrow. And Friday. We're doing a little break. The graphs come back.